In this example, we will prove the sum and difference identities. In Part A, explain how to construct the diagram shown. We need to construct this shape before we can prove the sum and difference identities. Construct the line AB. Define the length of this line as 1 unit. Construct angles alpha and beta by rotating the line. Label the points C and D. Now we need to make some right triangles. Our first triangle can be made by dropping a line from point D to point E. Our second triangle is made by dropping a perpendicular from point D to point F. Our third triangle is made by dropping a perpendicular from point F to point G. We have now completed the first part of the construction. In Part B, explain the next steps in the construction. Bring back the construction from Part A. We can construct another triangle by drawing a line from point F to point H. Now we need the angles in the triangle. In geometry, a line, called a transversal, that passes through two parallel lines has identical interior angles. Use a transversal to find angle alpha. The angle inside the triangle is 90 degrees minus alpha. All angles in a triangle add up to 180 degrees, so the angle at point D is 180 degrees minus 90 degrees minus 90 degrees minus alpha. Distribute the negative through the brackets. Draw angle alpha inside the triangle. We have now completed the construction. The proof of the sum and difference identities can be completed with this information. In Part C, state the side lengths of all the triangles. Bring back the construction from Part B. We'll color the first triangle blue. The angle can be written as alpha plus beta, the sum of the two individual angles. Use basic trigonometry to find the side lengths. Label the sides of the triangle. We'll color the second triangle green. The angle is beta. Use basic trigonometry to find the side lengths. Label the sides of the triangle. We'll color the third triangle red. The angle is alpha. Use basic trigonometry to find the side lengths. Label the sides of the triangle. We'll color the fourth triangle orange. The angle is alpha. Use basic trigonometry to find the side lengths. Label the sides of the triangle. In Part D, we'll prove the sum and difference identity for sine. Bring back the construction from Part B. We know from the blue triangle that sine of alpha plus beta is identical to the length of DE. The line DE is the sum of DH and HE. We don't know the length of HE, but we do know the length of GF. Replace GF with AF sine alpha. Also, replace DH with DF cos alpha. Replace DF with sine beta and replace AF with cos beta. We have now proved the sum identity for sine. Now that we have proven the sum identity, we can use the result to get the difference identity. Replace beta with negative beta. Simplify using the even and odd identities. Simplify. We have now proved the difference identity for sine. The sum and difference identities for cosine can be proved using a strategy similar to that shown here.